Picture this. It's Black Friday. Your checkout service is humming along. A customer clicks buy. And in that single moment, your code has to charge their card, update inventory, send a confirmation email, notify the warehouse, and update your analytics. So you wire it all up the obvious way. Checkout calls payments, then it calls inventory, then email, then the warehouse, then analytics. 5 calls, one after another. And then, the email provider has a slow afternoon. Suddenly, every customer clicking buy is stuck, waiting on an email server that has nothing to do with whether their order succeeded. Your checkout is now only as fast and only as reliable as the flakiest thing it depends on. This is a problem message brokers were born to solve. So let's talk about what they actually are. A message broker is a piece of middleware that sits between your services. Instead of Service A calling Service B directly, Service A writes a message, hands it to the broker, and moves on with its life. The broker holds on to that message, and Service B picks it up whenever it's ready. The magic word here is decoupling. The producer, the service sending the message, doesn't know who's going to read it. The consumer, the service reading it, doesn't know who sent it. They never talk directly. They don't even have to be online at the same time. Go back to our checkout. With a broker in the middle, checkout does one thing. It publishes an event that says an order was placed. Then it's done. It responds to the customer instantly. Meanwhile, inventory, payments, email, the warehouse, and analytics each pick up that event on their own schedule, at their own pace. Now, what does this actually buy you? 4 things. 1. If a downstream service is down, the message just waits safely in the broker until it comes back. Nothing is lost. 2. When traffic spikes, the broker absorbs the burst. Your consumers drain the backlog at a rate they can handle, instead of falling over. 3. Adding a new consumer is free. Want to add a fraud check? Just subscribe to the order event. You don't touch the checkout code at all. And 4. The broker's log can become your record of what actually happened, a built-in audit trail. But here's where a lot of tutorials lie to you. They make this sound like pure upside. It is not. Going asynchronous has a real cost, and in an interview, naming that cost is what makes you sound senior. You trade simplicity for scalability. You get eventual consistency. The read side of your system lags behind the write side. Debugging gets harder because there's no single call stack to follow. And you inherit a whole new class of problems. Duplicate messages, out-of-order messages, and messages that fail over and over. So here's the rule of thumb worth memorizing. Use a broker when the caller doesn't need the answer right now. Placing an order, the warehouse doesn't need to hear about it this millisecond. Perfect for a broker. But checking whether a password is correct, the user is standing right there waiting. That's a synchronous call, and forcing it through a broker just makes it worse. Let me leave you with the one distinction that everything else in this series builds on. There are 2 families of brokers. The first is the queue model. A message goes to one consumer, and once it's acknowledged, it's deleted. Think RabbitMQ, Amazon's simple queue service, Azure Service Bus. The second is the log model. The message is kept around for a set time, whether it's been read or not, and many independent consumers can each read it at their own pace and even replay it. Think Kafka, Kinesis, Pulsar. Queue versus log. Deleted after read versus kept and replayable. Burn that into your memory because it is the backbone of every "which broker should I use?" answer you will ever give. In the next episode, we'll zoom into the core patterns these brokers use. Point-to-point, publish-subscribe, streaming, and the humble dead letter queue that quietly saves production systems every single day. See you there.